Hello students, welcome back to the another session of data structure journey. Today we are going to learn the priority key, which is a special category of a queue. So first we have to know, and we also implement in the C language by help of the linked list. The priority queue is a category of linear queue where each element associated with the priority queue. It means that we are not going to store only the information. Information is associated or data is associated with some priority value, and they are arranged on the basis of priority value. Means high priority value is given to the element is going to be deleted first. This is called as the priority key. Elements with higher priority is inserted and deleted before the element with the lower priority. So whenever any element is inserted into queue, at that time what happened, the queue is arranged on the basis of priority, so that whenever you go for the deletion, the highest priority value is going to be deleted. Just think about the real case, that is the whenever in flight onboarding is going on, at that time what happened, the crew members are announced that all the people has to be in a proper queue, but at that time they added one more statement that old senior citizen, women carry babies are come to the first. Come to the first means they have the high priority value. So that what happened? They are inserted into the queue. If they are inserted means people are inserted into the queue with the priority value of the senior citizen or women carrying the baby. They are going to be into the flight on is the first means they are inserted into the queue first on the basis of priority value, that is the priority is senior citizen, and they are deleted from the queue on the basis of priority value. So this is called as the priority queue operation. Means whenever a data is entered into the queue on the basis of priority value, it's going to be inserted into the queue in such a way that highest priority always in the front of the queue. So whenever deletion operation is performed, the highest value is going to be deleted first. This is the main concept of priority queue. When we add an item inside the priority key, it is inserted in the priority based on the priority value. So what is the property of a priority key? Each and every item has a priority associated with it. Means data is associated with the priority value. An element with high priority is DQ before the element with the low priority, because the high priority value is stored in the front of the queue. If two elements have the same priority, they serve according to their order in the queue. Means fast come, fast out. The element is the inserted in the first queue with the same priority is going to be deleted from the queue first. Type of queue. So there are two types of queue. First one is the ascending order priority queue. Second one is the descending order priority queue. Ascending means the element with least value has the highest priority. We cannot say the priority with value which more means priority is below. No, no, no. Depend upon the which order we are maintaining the our priority key. Here what happened? This is the here what happened? We store the data with their value as per the priority value. Means 70 is the data, means 70 is the priority value. 65 is the data, means 65 is priority value. We are arranging the data on the basis of priority, means they have their own priority with it. Means 10 means priority is 10. So now this is in the array. In the array means it is the representation of the queue. Here what happened? 10 has the highest priority because it has the lowest value. So this is case of ascending order. Descending order is totally reverse, means the element which has the highest priority value is going to be deleted first. It has the highest priority value. So next question, how we can able to implement the priority queue? Priority queue we can implement it by using the array or by using the linked list or heap, binary search tree and binary heap. So for the array, what happened? We required the maxic min heaps, which we are not covered till now. So I am going to implement in the linked list, which is we are already covered in our previous video. So for that, we have to require to understand little bit about the single linked list. So hope you are able to know the what is a single linked list. I also make in the description section what is a single linked list, so that you can refer the things and you can able to easily understand. So here what happened? Implementation of priority key using the single linked list means what is a linked list? Linked list is a list of elements connected through a node. So here what happened? Node store the information as well as the address. And node are connected each other. So here what happened? Node are connected to each other. Single linked list, we know that the data stored as well as the address of next node is stored to value. Information we store next node, next address, and it will link together. It is linked together. This is the concept of single linked list, and we have stored the information of start here. Once we store the information of start address of the start node, then we can access the entire linked list. This is the null. Here what happened? Information. Right now, information in our priority queue is two things. First one is the data as well as the priority value. Now the node consists of three things. First one is the priority value. Second one is the data. Third one is the address of next node. For example, we are maintaining the ascending order. Ascending order means lowest priority value is going to be delete first. For example, we insert in the data that is here, for example, 15 is the data, priority value is 5. It means that if any data we want to store, here it is 7, data is 10. Then this is the priority value is 9 and the information we store the 20. Then here, for example, priority value is 10. So now this is the ascending queue because 5, 7, 9, 10, these are the priority. This is the information passed. For example, this is the first node, second node, third node, fourth node. So it store the address of 200, it store the address of 400, it store the address of 400. This is 300. Start store the address of 100. So it's 1 to 3. So this is our linked list representation of the priority key with the value, priority value, priority with the data value, that is 5 with 15 data, 7 with the 10 data, then 9 with the 20 data, priority value 10 with the 25. So this is the representation of the priority. For example, we want to store another information, that is, for example, priority value is 6 and data is the 15 or 25, for example, or 35. For example, the data we want to store, that is simple 22. We want to store 22 and the priority value is 6. So now next question arises that if we want to store the data, so first we have to check priority value 6 because it is a priority queue implementation. So we have to check. It is ascending means we have to search for a specific location. 5 after 5, 6. So we have to search. Each and every time we have to compare the priority value with this newly connected node. So for example, to store this value, what we have to do? We have to create a node, store the value of priority value, store the data value, and we have to next search which position we have to insert the value. So first position we have to check 5 is less than 6. So we have to search which location. Now after 5 it is okay. If after 5 if you enter it is good. Then what we have to make? We have to make a connection from this connection node to this connection. Then we have to make this connection. Now what happened? Our new node or new information we can enter into the data. Remember, if a priority queue, if this is a front, we can think it is a front or this is a rear. Here is not like that because from the rear side we are not going to insert the data. We insert the data as per the priority value. So if it is a simple queue, then what happened? This node will be linked to this value. But as it is a priority queue, whenever enqueue operation or insert data into the queue is going to be performed, at that time, the node is created and we store the priority value and information value. After that, we have to search the which is the proper location or proper position associated with the priority value of the new node. According to that, for example, we want to insert another value, that is the priority value is 2 and the data value is 50. Then what happened? We have to search for priority value 2. So priority value should be before that. So what we have to make? We have to make 2 here, 5. Then we have to make the connection and we may have to make the start. So this is the procedure, means how to insert into the first position of a single linked list, how to enter into the element into a specific position. Algorithm is same. If we know linked list, then it is easy. For data structure, minimum we have to know what is array, what is the array operation, what is a single linked list, what are the operation. If we know the two concept array as well as linked list, then what happened? All the data structure we can able to cover by help of the array as well as linked list. So here the same concept. Why I am not cover the array? Because for the array we require the maxip and minip, which we are not covered. That's why I go for the linked list implementation. So this is the way we have to insert a node. So for this is for the NQ operation. Second one is the DQ. DQ means delete an element from the queue. So delete means simple. This is ascending order, means the lowest priority value as the highest. So now what happened? As it is already in the sorted order of on the basis of the priority value. So what happened? This element is going to be deleted. So front, this is, we can say this is the start, or we can say this is the front end. From front end we can delete the value. So it is the simple way. So deletion means DQ is the deleting an element from the first position of a single linked list. Same logic we have to follow here. So it is very easy. So what we have to make? For example, I make this is as a temp. So first we have to make a pointer temp point to this one. So what we have to write down? Temp equal to start. Then start equal to start next. Means now start points to this node. Then we have to write down printf which value? Temp info or data, whatever we write down, temp info is going to be deleted. After that we have to free temp. We free temp means we release the memory is gone. After that, what happened? This is the priority queue is present. So the same thing we have to perform whenever we have to go for the implementation of priority queue using the linked list. So what are the operation we can perform in the priority queue? First one is the NQ operation. NQ is the when a new element inserted into the priority key, it is inserted on the basis of priority value. So it serves the proper position, then insert it because it is a priority key. If second operation we have to perform DQ. DQ means deleting an element from a priority queue. As data is already sorted by the priority value, so it retries from the first element of the queue. This is the front side we have to delete. Next operation we can go for pick operation. Pick operation of the priority value means it retry first value from the queue, means whatever the highest priority value of the queue is going to be retry without deleting. In case of DQ we are deleted that item, but in case of pick we just retry the information. We are not going to delete the value. So next we have to go to the implementation in a C language. Let us start the implementation phase. So here we have to write down that is implementation of priority queue using linked list. You have to include the header file also. Now we have to declare the structure. So in our structure declaration, I use the type def because I don't want to write down each and every time the node structure node. So that's why I make the type def. So here we have to store the priority value. So first integer is the priority value. Then next integer is the data we want to store. Third one is the pointer to the next node. Next. So then we have to write down a semicolon. And for example, here I make the there is No need for front or rear because insertion is done on the basis of the priority value. So I make only the one start the pointer points to the first node. And we have to make the start node as a null. If you make this one as a front, no issue. So first we have to write down the function for empty. Is int empty. Empty means our queue is empty or not. For that we have to write down is empty. Sorry, I make it as a int empty. Is empty. Then what is the condition? Condition is that if the start equal to null, then our queue is empty. So we have to check if start equal to null, then return 1 means it is true, else return 0. So our is empty function is completed. Then we have, so next function we have to write down enqueue. There is no is full function is required. Reason is that it is a implementation of the linked list. So we have to go for the enqueue operation. Enqueue is the insert an element into the queue. As I have already told that I always prefer to make the function simple because I don't want to make complicated. That's why I make each and every function does not take any parameter, does not return any value. Okay, so now here to store the priority value, we require a variable p, and d is to store the data value entered by the user. So anyhow, first we have to allocate the memory. So store current is the node where we have to store the allocate memory address. First we have to allocate the memory by help of the malloc function. We don't know how much memory is required. That's why we are using the size of operator to calculate how much memory is required. At that time, we have to check whether memory allocation is done. Very rare chances memory allocation is not done, but anyhow, we have to check it. If it is null means memory is not done. So we have to write down printf. Else means memory allocation is done. Once memory allocation is done means we have to ask the end user to enter the data with the priority value. So we have to write down printf new line, please enter the data into queue. Then we have to scan it. And we have to store in the D. Then similarly, we have to ask the user to enter the priority value of data. And we have to store inside the D. Then we have to store the data part. We have to store the data part. Which value? D value. Then we have to store the priority value also. To P. We store the priority value as well as the data value. Next thing we have to search which location we have to store. So for that, what we have to do is check whether queue is empty or not. If the start equal to null. If it is null means what? Queue is empty. If queue is empty, then what we have to do? We have to make the start equal to current, and we have to make the current next equal to null. or we can write down the start next, the both the things same thing, or you can make it the letter. We have to make the start next equal to null. So all the information of the for MTQ is over. Then what we have to make? We have to go to the proper location. So we have to make the start equal to temp. So temp is a pointer where we are going to store the start value. So we have to declare the pointer also node star. Temp means pointer is a temp is a pointer points to the node type of structure, node type of start. So if if temp, whether we have to insert in the first location or not. For that we have to check temp which value, priority value. If temp priority value is greater than the current priority value, then what happened? We have to make the current next equal to, we have to insert into the first position equal to start, not start, we have to make the temp is the start, same thing here, then start equal to start next. Indirectly we make the, okay, means we insert into the first position. Otherwise what we have to do? We have to go to the proper position. So proper position means else while temp next not equal to null. Not equal to null means last of the linked list, or both the conditions should be same. Then only it can be possible. So we make the null or priority value. Priority value is less than current priority value. So this is the location we have to insert. What are the things we have to do? We have to make that is temp equal to temp next. Temp equal to temp next. Then we reach the proper location. Once we reach the proper location, then what we have to do? We have to insert the value, insert the node. So current next equal to temp next, then temp next equal to current. Means current means the new node. So insertion is completed. So this is our insertion function is over. Then we have to go for the DQ. DQ is very simple because already data is inserted as per the priority value. So front end we are going to delete. So we have to check whether data is present or not. Is empty. Is empty. If it is true, means Q is empty. So we have to write down printf new line Q is empty. So deletion cannot possible because Q is empty means we cannot delete. Otherwise, else we have to store temp equal to start. So here we have to declare the pointer of a temp. Then we have to print the which value is going to be deleted. So printf then we have to make the start point to the next node. Then we have to release the memory by help of the free function. So our deletion is completed. Deletion is completed. Now we have to write down the display function. So void display. So whenever we go for display, we have to check whether data is present or not. So is empty function we have to use to check whether queue is empty or not. If it is queue is empty, then what happened? We have to write down printf new line queue is empty underflow condition. Then else means data is present. If data is present, we have to print the value. Printf new line queue elements are then we have to store temp equal to start and we have to declare also what is a temp. Temp is a pointer points to the node of a structured type of data. So now then we have to print the value then up to how much? While temp is not equal to null means it is end of the queue. Then we have to print the value printf %d then one tab here we are not mentioned. After that it should be a new line. Okay, then once the data, which data it will print? It will print the temp data. Temp, whatever the data to the value it will print, then temp equal to temp next, it points to the next node. So this is our display function is completed. Once display function is completed, then we have to go to the write down the main function. Or one more function we can add, that is the pick function. Pick function is used to pick the topmost element. So pick also we can make this one. So here, whenever you retrieve the topmost element, we have to check data is present or not. Is empty means queue is empty or not. We will check. If queue is empty, then printf new line queue is empty. Else, what we have to do? We have to retrieve the front element or start element. So printf %d is the picked element. So it is start data. Here the pick of the sun and should be done. So this is our pick function is over. Then we have to go for integer main. So main here the menu type program. So we need the choice. So I make the choice as the integer data type. Then printf new line priority queue implementation using linked list. After that, new line should be created. Then we have to write down options. What are the options we have to write down? One is for enqueue of priority queue. After that, new line should be created. Then DQ. Then pick Then fourth one is display. Then dynamic. Then scanner. Sending 1% choice. So these things should be in the do while statement. So I have to go for do. So this is our do while. Then whatever we have to put in the switch case, switch case, that is choice. And case one, that is which form we have to call the function enq function. Then pick function. What one is the display function? Then we have to write down the break. So this is switch case server. Then after that, this is our do while, means while choice is not equal to 4 or 5. This is the main function is completed. Let us compile the program whether getting correct answer or any node. Okay, size of node malloc. Display spelling mistake. Then let us come on the program. So first, for example, we enter the value 10 with the priority value is 2. Then again we insert the value 30, priority value is 5. Then we go for display, it will display 10 and 30. 2 is the priority value. That's why it come to the first. For example, we insert another value and priority value in between 2 and 3, that is we enter the 3. 1. Value is 40, priority value is 3. Let's go for display. Yes. 40 is inserted in between the 10 and 30. Reason is that we insert the priority value is 3. So now we have to go to pick the value. So pick value is 10. This is the topmost front element. So this is the 10. If we go for delete an element, so which element is going to be deleted? Highest priority 10, then 40, then 30. So this is the implementation of the priority queue by help of the linked list. We are already got the correct answer. So we have to know what are the application of queue where we can able to use. These are the shortest path algorithm. So these are the algorithm is present where we have to use the priority key. In also operating system, we use the priority scheduling, role balancing, interrupt handling. So these are the area where we We can use the priority queue. Upcoming session, whenever we go for graph data structure, at that time we will try to cover the application of the priority queue. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so much.